Alright, this is Algebra 2, Week 4 Logarithm Review. Number 1, the value of a new car depreciates over time. Greg purchased a new car. The value V of his car after 2 years can be modeled by that equation. What is the average decreasing rate of change per year of the value of the car from June 2012 to 2014 to the nearest $10 per year? Alright, so the key here is that he bought the car in 2011 and T years after he bought the car. So we need to plug in a 1 for the T and we need to plug in a 3 for the T and then find average rate of change. So we have log 0.8 V over 17,000 equals 1, and then we have the same thing. Your phone's ringing. When we plug in the 3. So we have to solve both of those for V. When you have a log on one side of the equation only, you make sure that log term is isolated, which it is, and then we're going to change it to an equivalent exponential equations, which many students call it the circle thingy. So the base is 0.8, the exponent is 0.1, and that will equal V over 17,000. So if you put the 0.8 over 1, cross multiply, you will get V equals, well, let's see what 17,000 times 0.8, and you get 13,600. And if we do the same thing here, we get 0.8 to the third equals V over 17,000. Cross multiply, so 0.8 caret 3 times 17,000 is equal to 8,704. And now we have to take the average rate of change, which is y minus y, so the value minus the value over the time minus time, because time is always an x. Well, that was 13,600 was after 1 year, so 1 minus 3. So 13,600 minus 8,704 is 4,896 over negative 2. And we get negative 2,448, but it said the nearest $10, so 48 rounds to 50. So the rate of change is 2,450. They said a decreasing rate of change, so they just wanted the amount, and that's why they didn't put the negatives on the choices. Alright, number 2. After examining the functions, f of x is equal to the log of x plus 2 and g of x is equal to e to the x minus 1 over the interval from negative 2 to 3, Lexi determined that the correct number of solutions is. Alright, well, we're going to put this in our calculator. So we have ln x plus 2, and then in y2 we have e caret, make sure the x minus 1 is in parentheses. It's an exponent with more than one piece. I'm going to hit graph. And my graph makes it very hard to tell. So I am going to hit zoom and go in. Hit enter. And when I hit zoom and hit enter, I can see that that graph is going to cross twice. Now don't forget to change calculator back, so hit zoom number 6 for standard. Alright, number 3. That equation relates time t in years to the amount of money A earned by a $5,000 investment. Which statement accurately describes the relationship between the average rates of change of t on the intervals of 6,000 to 8,000 and 9,000 to 12,000? Okay, so we need to find average rate of change for both of them. A is the amount of money earned, T is the time. So, alright, so here T is the Y value, which is very odd. So the investment amount is our X value, which is very strange. So all we got to do is plug in the 6,000 and 8,000, and that will find us our T, which is in fact this time our Y value. So we have this, and then we are going to do it again with 8,000. Alright, so be careful when you type this in your calculator. We've got parenthesis 1 divided by 0.0105 n parenthesis ln automatically opens a parenthesis 6,000 divided by 5,000 and hit enter, and I've got 17.364. Okay, I'm rounding to 3 decimal places because I just want to know which one's larger. Alright, so now I'm going to type that in again, except this time I'm going to do 8,000 divided by 5,000. And I get 44.762. So if I find the average rate of change, remember those T's, which is unusual, is the Y value this time. So 44.762 minus 17.364 over, this was 8,000 minus 6,000. So 44.762 minus 17.364 is equal to 27.398 divided by 2,000 is equal to 0.013699. Alright, now we got to do it again for 9 to 12. Alright, so I'm just going to put 9,000 here and 12,000 here. Okay, that's the interval. Intervals are always X values. It's another way to tell. I'm not going to rewrite me substituting it in because all I'm doing is the same thing, just changing the numbers. Alright, so when we plug in 9,000, I'm getting 55.980. And when I plug in 12,000, I get 83.378. So when we do average rate of change, 55.980 minus 83.378 over 9,000 minus 12,000. And this time I'm getting 0.009. So 0.013 is bigger than 0.009, so it's bigger from 6,000 to 8,000. Number 3. So this really had nothing to do with logs. It was just a matter of plugging in and doing average rate of change. Number 4. Which expression is not a solution to this equation? Alright, well, 2 to the t is equal to the square root of 10. In order to solve for t, you have to isolate the term that has the variable exponent, which it is. Then we're going to log both sides. So log 2 to the t equals log square root of 10. And then the reason for doing that is the exponent now comes down in front and multiplies. And divide by log 2. So t is equal to log square root of 10 over log 2. Now, they didn't ask us to actually calculate the thing. But I don't see any of those answers that's the same. So let's see if we can write it different. T is equal to log x square root is a 1/2 exponent. And that's still not helping me much. Alright, so here's what I suggest. I can type this into my calculator and come up with a value because it's a common log. It has a little base of 10 because there's no base written there. And we can get a value. So we're going to type in log square root 10 and the parenthesis twice, one for the radical and one for the log, divided by log 2 and parenthesis, and I'm getting 1.66096, etc. Now I'm going to use the change of base formula for each one of these expressions and see which one does not give us the 1.66. So the change of base, all right, we're going to have 1/2 times. Change of base says you take the number on the same level and then divide it by the log of the little base. So I'm going to type in 1/2 in parentheses times log 10 n parenthesis divided by log 2 n parenthesis and hit enter, and I get 1.6609, so that one matches. So this one I'm going to type in log square root of 10 divided by log 2, which actually is exactly what we typed in to get the 1.66 to begin with, so I don't even need to check that one. If we do change base on number 3, it's going to say log 10 divided by log 4. So log 10 n parenthesis divided by log 4 is going to give us 1.6609. So this one, I'm guessing, is the answer. Change of base is going to be log 4 divided by log 10. And log 4, remember log 10 really just has a value of 1. And this one turns out to be 0.602. So number 4 is the one that is not the same. Alright, number 5, graph the following function on the axis below. The base is not a 10, that means we need to change the base formula. So it's going to be the log of whatever's on the same level divided by the log of the little guy. And we need to go get ourselves a table of values. Now if you just type that in and hit graph, you are not going to see an accurate picture because your calculator can't handle drawing to that extreme. But what you need to remember about log graphs is they go to infinity in both directions. Alright, so if I hit graph, it looks like it ends at like 3, but it really doesn't. Okay, it is going to go on forever. So second table, and alright, so it went to 2. So I am seeing -3 is like 1.46, -2 is 1.26, -1 is 1, 0 is 0.6, 1 is 0, and then at 2 I get an error. Where I get an error tells me that that's where I have an asymptote. So I am going to draw a dotted line at x equals 2. My graph will not go any farther than x equals 2 any farther to the right, but that also tells me that that's where my infinity is going to happen. So -3, 1 and about a half, -2, 1 and a quarter, -1, 1, 0.6, 1, 0, and then I get my error. So I'm coming from this direction, and I will go toward infinity. Make sure you don't hit your dotted line. Don't try to draw it to the bottom of the graph. Just draw it near and draw your arrow showing that it's going to infinity. Same thing on the left. Don't go too far. If you make it too steep, they can take off points for accuracy. So I just go a tiny ways and draw that. So this is my f of x, and there it is. state the domain. Domain, left to right, negative infinity. And it goes until 2, but it won't hit the 2, so it's a round parenthesis. Equation of the asymptote is the vertical line, x equals 2. That's where the error starts. Number 6. If that equation e to the bt equals c, a, b, and c are positive integers, they want to know what t is. So they want you to get t by itself. So ae to the bt equals c. Anytime you have a variable for an exponent you need to solve for, you're going to need logs. Before you can use logs, you need to isolate the term with that variable exponent. So that means you've got to get rid of the a, so you get the expression e to the bt by itself. So first thing we're going to do is divide both sides by a. Now we can take the log of both sides. The whole point of taking the log of both sides is to bring that variable exponent down. Oops. And if I have an e, I should be using an ln log. Excuse me. Okay. Alright, and now I want to solve for t. We have had a couple discussions now from these review sheets that the log of e is equal to 1, because on a natural log, the little base is e. Log asks the question, what exponent do I put on this base to get e for an answer? Well, I put a 1 on there. So this is equal to 1. I usually circle it and put the 1 so the graders know I realize that. And dividing by 1 doesn't do anything, so I'll ignore it. Divide both sides by b. So t is equal to the natural log of c over a, all divided by b, which is number 3. Number 7, for which values of x rounded to the nearest hundredth will those things be equal? You have a couple of options here. One of the options is just plug in the answers and see what works. So you would type in absolute value of 2.29 squared minus 9 and see what you get. And then you have to do change of base for this guy. So you would do log of 2.29 divided by log of 3 and see what that answer is and see if they match. So let's do that. Math, num 1 is absolute value. 2.29 squared minus 9, end parenthesis. I'm getting 3.7559. And the other one, I'm going to get log 2.29, end parenthesis. If you don't, you'll have an order of operations error. Divided by log 3, and I'm getting 0.754. So that doesn't work. Pick a different one. Okay, well, let's just try the next one. So I'm going to put 2.37 in here and see what I get. And I'm going to put 2.37 in here and see what I get. I guess I'll be good and write it out. So 2.37. So go back and do math num 1. And 2.37 squared minus 9. Uh-oh, I forgot to subtract 3 on the last one. Guess what, guys? I blew it. Alright, so I forgot this minus 3. If I subtract 3, then my answer is 0.7559, and this is 0.7554. That's really close. So that's a good possibility. Let's put in the 2.37 and see what happens anyway. So I get 0.383. And then if I do the logs, log of 2.37 end parenthesis divided by log 3, I'm getting 0.785, not even close. Alright, so it's definitely not number 2. I'm really starting to think number 1's a good possibility because the answers are so close. So what I'm going to do now is go back and check the 3.63. So absolute value of 3.63 squared minus 9, minus 3 on the outside. log of 3.63 divided by log of 3. See what we got. So math num 1, 3.63 squared minus 9 in parentheses minus 3. I'm getting 1.1769, and log of 3.63 n parentheses divided by log 3, and I'm getting 1.1735. Both of those answers give you really wicked close decimals, so we are going to pick number 1. The only other option you've got is to go ahead and graph them. You could put that into y equals. You can do change of base and put that into y2. The only problem is you really need to know how to do the intersection on your calculator to go find it manually. But if you remember how to do the intersection, that is another option for you. Alright, number 8, last one for this video. Graph this log equation. Again, you're going to need to change of base. So log of x plus 6 n parentheses divided by log 2. Alright, so go to y equals and type it in. Make sure you end your parentheses after that 6. Then divide it by log 2. Go get a table. And this time the error happens at -6. So I'm going to put -6 error. That's where my asymptote will be. Then I get a -5, 0, a -4, 1, -2, 2. That might be good enough. So -6, 1, 2, 3, 4, 5, 6. There's my asymptote. -5, 0, -4, 1, -2, 2. So I'm going to come this way. Remember, get close to the asymptote, go straight down, draw an arrow, and then draw it this way. Do not draw too much. F of x. Alright, part 2 will be posted later.